Hello, my name is Lee and my partner is Nathan, and today we're gonna talk about remote controller for RC vehicles using Arduino. The objective of this project is to make a fully featured remote controller to drive an RC vehicle, and for the purpose of testing we are using a quadcopter. Let's talk about the controller. Our controller is using two joysticks to control the quadcopter. In order to read that data from the joystick, we're using an Arduino Uno, and to transfer that data to the receiver of the drone, we're using a radio transceiver. To receive the data from our controller, we are using a Arduino Uno and another radio transceiver. The signal then will be sent to an Arduino Duong, and it will act as a PWM manager, and through that the signal will be sent to our flight controller, which will do all of the dirty work to control the quadcopter. We were able to transfer the controller data to our receiver successfully. However, we ran into some problems when we were trying to feed that data into our flight control, and this is where things get a little bit nasty.
We suspected the flight controller accepts a PWM signal by testing the outputs from a commercially available transmitter-receiver pair. To do this, we powered the transmitter and then used a pulse-in function which read each of the jumpers on the receiver. The values we read in correspond to the position of the joysticks on the transmitter, so we concluded we must also construct a PWM signal from our custom remote to the flight controller. Analog write from our receiver Arduino. We assumed analog write function should output a PWM signal encoding the value we pass to it as a parameter, as long as it is from 0 to 255 on a specified PWM enabled pin. However, we did not see successful results from this method. After some research, we decided to construct our own PWM signals using a method called bit banging. This method involves writing high or low to a digital pin to generate a PWM wave. A PWM signal can encode our value by leaving the signal high for our numeric value in microseconds. This method does not come without its own obstacles. Since this method is very time sensitive, we could no longer send the PWM signal from the same Arduino we used to receive the radio transmission. If we were to do this, the amount of time it would take to read in the data from the radio transceiver would inhibit us from managing the PWM signal. It simply takes too long to read in from the radio, so we added an Arduino Duong to our design, where its sole responsibility is to manage the 4 PWM signals. Of course, then we must find a way to get the values we want to encode into our PWM signals on the Duong. To have the values available, we sent 4 bytes of information over serial from the receiver Arduino to the Duong.
With all of that, we were able to send the data from our remote controller to the flight controller. Through the calibration software, we saw corresponding changes based on the movements of the joystick. However, there was a big delay between the time of the input and the display output. Therefore, our controller is not ready to flight. In addition, we don't want to damage our equipment because we borrowed some of the components. We need to improve our design before we fly with our controller, specifically to find a better way to send signals from the receiver to the flight control. Either figure out a way to send PWM signals straight to the flight control, or implement more efficient bit banging. And that is the end of our video. Thank you for watching.